Quantum computing. It sounds like something straight out of science fiction, doesn't it? You know, the kind of tech that's always just over the horizon.
Totally. Except, well, what if that horizon is actually rushing towards us?
Right. And what if it poses like a direct threat to the very foundations of our digital world, especially things built on cryptography like blockchain?
That's pretty much the reality we're starting to face. The mathematical puzzles that protect, well, everything from encrypted messages to your crypto assets, they're potentially vulnerable to the immense power of quantum computers.
And that specific challenge is exactly what we're going to unpack in this deep dive. We're focusing on how this looming quantum threat impacts blockchain.
And specifically, one network that seems to be tackling this threat head-on, proposing a really detailed plan, IoTeX.
Yeah, and our source material here isn't some, academic paper or just a news report. It's actually something much more direct.
All right, it's a proposal from within the IoTeX community, an IIP, which stands for IoTeX Improvement Proposal. This one's called IIP-Qubits.
Or the Quantum Resistant Upgrade Initiative, the QRI.
Exactly.
Okay, so let's break this proposal down. Our mission here is to guide you through the core of it. What's the actual threat? What's this multi-part plan they're suggesting? And what does it all mean? Not just for IoTeX, but, well, potentially for any blockchain thinking about a post-quantum future.
Yeah, and here's where it gets really interesting, because this isn't just about, like, theoretical code breaking.
No, it's about protecting actual real-world stuff, assets, devices, data that are connected to the blockchain.
Precisely. And that sense of urgency is right there at the start of the proposal.
Yeah.
They really emphasize that quantum computing isn't some distant dream anymore. It's a disruptive force, and it's gaining speed fast.
And they actually point to research that makes you sit up and listen, like findings from Google Quantum AI suggesting the resources needed to break common encryption, like RSA, dramatically reduced.
Yeah, like by a factor of 20 in some of their estimates, which is huge.
Huge. And crucially for blockchain, the proposal makes it clear. Elliptic Curve Cryptography, ECC, that's the backbone for wallet signatures, validators on IoTeX, and, well, most modern blockchains.
Pretty much all of them, yeah.
It's also vulnerable, fundamentally vulnerable to these quantum computers.
So it's not just about older stuff like RSA. This proposal frames it as a definite countdown. You've got nation states, big tech companies pouring money into quantum R&D. The clock is seriously ticking for standards like ECC.
Okay, so what's the actual consequence? What happens if someone has one of these powerful quantum computers?
Well, the big one is Shor's algorithm. It's specifically designed to crack the math problems that ECC relies on.
Yeah.
So an attacker could potentially take a public key, which is, visible on the blockchain for everyone to see,
Right.
and use a quantum computer to work backwards and figure out the private key.
And if you have the private key,
Or
game over, right?
pretty much. You can sign transactions as that person or device. So forging transactions, yeah. Taking control of accounts, definitely. Maybe even messing with the consensus itself, because signature verification kind of becomes meaningless if the keys aren't secure.
Wow. Okay. Now, the proposal makes a point about why IoTeX specifically feels it can't just, wait and see how things play out.
Right, because unlike, say, Bitcoin, which is primarily a financial ledger, IoTeX is building this machine-fi economy. It's integrating real-world devices, physical data, actual assets using deep-in, decentralized physical infrastructure.
That feels like a key difference.
It's critical. Because IoTeX connects physical and digital, a quantum attack isn't just about losing some tokens online. If you can compromise the identity of a trusted device, or fake the data it's sending,
That could ripple out into the real world, supply chains, connected systems.
Exactly. So the proposal argues IoTeX is a really high-value target, and the stakes are just much higher. Waiting until the threat is immediate. They see that as way too risky. They feel they have to prepare now, proactively.
Okay, that makes a lot of sense. So let's dive deeper then. The specific threats outlined in this proposal and what they mean for the IoTeX network itself.
So, okay, at the protocol level, like we said, the main thing is ECC being vulnerable to Shor's algorithm.
Got it.
The proposal also mentions other common algorithms. RSA, ECDSA, they're breakable too. And here's the scary part.
Yeah.
This isn't just about stopping future attacks.
What do you mean?
An attacker could potentially harvest public keys right now, today, store them, and just wait. Wait until they have a powerful enough quantum computer and then break them later.
So they could potentially compromise past transactions or accounts.
Potentially, yeah. Expose historical private keys. It's a serious worry.
Wow, okay. And the proposal also translates these, technical risks into more tangible threats for people using the network. They talk about identity spoofing.
Yeah, especially for all those trusted devices and DPIN nodes connected to IoTeX. Imagine if a quantum attacker could forge a device's digital signature. All that trust built into the system. Gone. Instantly.
Okay, that's bad. What else?
Smart contract hijacking. Think about it. If the private key's controlling a contract, who owns it? Who can upgrade it, get compromised?
Right.
Someone could just take over critical parts of the ecosystem.
Right.
And they also mentioned loss of anonymity and privacy, particularly concerns around zero-knowledge proof systems if they weren't originally designed with quantum resistance baked in.
So looking at the whole network, the impacts could be, well, pretty devastating.
Oh, absolutely. Trying to migrate an entire network's core cryptography while under this kind of threat, it's a massive challenge. They talk about the risk of forks, chain splits, if the migration isn't perfectly coordinated.
It's just the fundamental loss of trust, right? If the basic security layer is broken.
Exactly. For developers, for businesses using IoTeX, for sensitive machine data, for everyday users,
Yeah.
if that cryptographic trust disappears, the whole value proposition of a secure, decentralized platform is just undermined. Could be existential.
Okay, so that's the problem. Pretty stark. What does the proposal actually suggest IoTeX do about it, this IIP-Qubits?
Right, this is the core of it. They lay out this big four-pronged strategy. They call it the Quantum Resistant Upgrade Initiative, or QRI.
4 prongs. Okay,
Yeah.
walk us through those. What's the plan?
Okay, prong one, the Cryptographic Transition Plan, CTP. The objective here is pretty fundamental. Swap out the vulnerable ECC stuff for new algorithms designed to resist quantum attacks. Post-quantum cryptography, PQC.
And they actually name names, don't they, in terms of which PQC algorithms they're looking at?
They do. They're focusing on algorithms that came out of that big NIST competition that's the U.S. National Institute of Standards and Technology. They mentioned CRYSTALS-Kyber.
Which is for key encapsulation, securely swapping secret keys.
Exactly. And then CRYSTALS-Dilithium.
For digital signatures, verifying transactions and messages.
Right, and they also mentioned CIFIN-CZ's Plus Score, another NIST standard, specifically for quantum-safe one-time signatures.
Okay, but they're not just flipping a switch overnight, are they?
No, that would be chaos. The plan suggests starting with hybrid models.
Yeah.
So using both the old ECC and the new PQC algorithms side by side, at least initially.
Okay, so that allows for a gradual transition, backward compatibility while things get updated.
Precisely. Makes the upgrade path much smoother. And a big part of this first prong is also doing a full audit, like mapping out every single place the current crypto is used. Wallets like IOPay, IOPayX, cross-chain bridges, smart contracts. You have to know everything that needs changing.
Makes sense. You need the full picture. Okay, what's prong 2?
Prong 2 is about getting the ecosystem ready. It's the ecosystem tools and SDK upgrade. Basically, give developers the tools they need to build quantum-safe apps.
Right, because changing the core protocol isn't enough if the developers can't actually use the new security features.
Exactly. So this means integrating these new PQC libraries directly into the tools developers use every day, the SDKs, the command line tools like IOCTL, the bridge software like IOTube. And they specifically mention enabling quantum-resistant identity schemas. That's super important for the machine-fi side, making sure machine identities and data attestations stay secure post-quantum.
And they also mentioned something about testing.
Yeah, a quantum readiness testing suite. This is really smart. It lets DApp developers test their own code, their own smart contracts, against the new PQC standards before they go live. Helps the whole ecosystem adapt securely.
Okay, that covers the tech and the tools. Prong 3.
Prong 3 tackles the huge coordination challenge.
Right.
Governance, communication, and migration plan. This isn't just tech, it's getting everyone on the same page. Logistical, social.
Yeah, getting a whole decentralized network to agree on and implement such a fundamental change, that sounds incredibly difficult.
It really is. So the proposal suggests using a phased approach, like a series of governance proposals, maybe IIP, Q1, Q2, etc., to walk the community through it step by step.
Makes sense. Break it down.
And they also talk about having quantum emergency procedures baked into governance, just in case unexpected problems pop up during the transition, planning for the unexpected.
What about the actual migration? How do they minimize disruption?
They suggest things like progressive opt-in models for the validators and nodes so people can upgrade gradually instead of one big risky hard fork.
Okay.
And to keep things running, they mentioned using parallel networks like testnets running the new PQC crypto alongside the mainnet and maybe dual key account that support both old ECC and new PQC keys during the switchover period.
Clever. Lots of thought going into managing the transition. Okay, prong 4.
The fourth and final prong is strategic alliances and interoperability. Basically, recognizing that, hey, this quantum threat isn't just an IoTeX problem. It affects everyone in blockchain.
So they're not trying to solve this completely alone in a silo.
Definitely not. The goal here is cross-chain resilience, aligning with what others are doing. They talk about maybe forming a post-quantum alliance with other big layer ones. They mention Ethereum, Polkadot, Cosmos as examples who are facing the same issues. Collaboration is key.
And I guess talking to the crypto experts, too.
Absolutely. Engaging directly with the researchers behind the NIST PQC standards, folks working on quantum-resistant ZK proofs, staying on the cutting edge.
Makes sense.
And crucially for IoTeX, given the Machine Phi focus, they need to coordinate with their dip-in partners, making sure the actual hardware, the firmware, and devices like their Pebble tracker can be updated to handle PQC, because that security chain extends right into the physical world for them.
Right, that physical link is vital. Okay, this sounds like a massive undertaking. How are they planning to fund all this?
Yeah, it's definitely not cheap. The proposal addresses that directly. It outlines creating a dedicated post-quantum security fund.
And how much are they talking about?
They propose an initial allocation of $8 million drawn from the IoTeX treasury.
8 million. Okay, what's that specifically earmarked for?
Several key things. The core R&D and implementation of the PQC standards themselves, obviously. Paying for crucial external security audits of the new code. You really need that third-party validation.
Absolutely.
Also, developer grants to encourage people to build or upgrade dApps using the new PQC tools. And finally, funding for marketing and community education, so everyone understands why this is happening and what they need to do.
Okay, $8 million sounds substantial. But even with funding a project this big, it's got to have risks, right? Does the proposal acknowledge challenges?
Oh yeah, they're quite upfront about the hurdles. One big one, maybe non-technical, is just adoption hesitancy.
Meaning, people might just not want to switch.
Yeah, getting everyone, developers, users, validators, partners, to really understand the urgency and actually go through the process of migrating.
Right.
That could be tough. Inertia is powerful.
True. What else?
Well, there are potential performance trade-offs. These new PQC algorithms, while quantum safe, might sometimes mean slightly larger transaction sizes, maybe a bit more latency, compared to the super optimized ECC we have now. That could affect user experience.
A technical trade-off?
And maybe the biggest elephant in the room, coordination complexity. It's just mind-bogglingly complex.
Yeah.
This is like performing a cryptographic heart transplant on a live, running, decentralized network.
Wow, that's a good analogy.
You have to sync up changes across wallets, bridges, every single node operator, every smart contract.
Yeah.
Getting that level of coordination right in a decentralized system, it's incredibly difficult. One slip-up could be disastrous.
Yeah, the coordination sounds like a nightmare. So how does the proposal wrap things up? What's the final message?
It really doubles down on the stakes. It states pretty bluntly that quantum computing could potentially nullify decades of cryptographic work in a matter of hours once a capable machine exists. And the very last thought in the proposal is basically a call to arms, acknowledging it's inevitable. It is not a matter of if, but when. Let us begin now.
Powerful stuff. Okay, so just to quickly recap this deep dive on the IoTeX IIP-Qubits proposal. The quantum threat to current crypto, including the ECC used in blockchain, is presented as very real, very imminent. It poses a huge risk.
Yeah, a fundamental risk to security and trust.
And the IoTeX community, through this QRI proposal, is putting forward a really comprehensive multi-stage plan. It involves switching core crypto, upgrading tools for devs, careful governance and migration steps, and importantly, working with others in the industry.
Exactly. It's a proactive approach to a challenge the entire space is facing.
And understanding proposals like this, well, it's crucial, isn't it? It's not just about IoTex's tech roadmap. It really shines a light on a critical issue for the whole future of blockchain, for DePIN, and for the basic security of your digital assets.
Absolutely. Being informed about how networks are planning to tackle these huge technical and non-technical challenges is just key if you want to stay ahead in this field. It's evolving so fast.
Which leads us to a final thought for you to consider, something that really stems from the sheer scale and complexity we've just discussed. Given the massive technical lift, and maybe even more so, the incredible coordination needed across a whole decentralized ecosystem, what do you think are the biggest non-technical hurdles IoTeX, or really any blockchain, will face trying to become post-quantum secure?
Is it developer pushback? user confusion, getting validators to actually upgrade, maybe something else entirely.
And maybe think about what role your involvement as a community member plays in making sure these essential but really difficult upgrades actually succeed.